Hello and welcome to the channel. Let's learn electronics. Let's have a quick recap of the last video. We studied a special type of diode which is called zener diode. This zener diode has the ability to conduct even in the reverse direction, in the reverse bias mode. And as you can see its characteristics curve, it conducts normally like a normal PN junction diode in the forward region, but when it comes to the reverse region, as long as the applied reverse voltage is less than the value of this Vz, is less than the value of the breakdown voltage, the diode behaves just like an open circuit. The diode ideally does not conduct, and the moment the value of applied voltage exceeds this breakdown value, this Vz value, then the diode starts conducting. A heavy current can flow in the diode and that too in the reverse direction, in this direction. And that makes the zener diode a special thing because its voltage is almost constant. It behaves like a battery. The voltage across it, as you can see here, is almost like Vz, but a heavy current can flow through it, and this is the magic of this device, zener diode. Last time we ended up our lecture on the applications of a zener diode, so this time we'll catch up from the same topic, the application. And the most important application of this device, zener diode, is a voltage regulator. Zener diode is the hero of the voltage regulator circuit. Now, what is a voltage regulator circuit? It is a special unit in a power supply system which is responsible or which has the duty to ensure that a constant voltage is available to the load in all the conditions. Sometimes the power supply may fluctuate, sometimes the load itself vary, but in any case the voltage regulator circuit will ensure that these mismatches can be handled safely and successfully. So this picture indicates a voltage regulator circuit. It has a power supply which is susceptible to fluctuations, and it has a load which can also vary. We need something which can handle its mismatches, its variations. एंड इसे आसान भाषा में समझें, इसे इजी एनालॉजी के साथ इमेजिन करें तो जस्ट इमेजिन इट इज एन अकेडमी और अ स्कूल एंड वी हैव अ प्रिंसिपल हेयर. दिस VI इज अ प्रिंसिपल और द इंचार्ज ऑफ द अकेडमी, एंड दिस RL ये है स्टूडेंट्स. अब टीचर भी कभी कभार बहुत स्ट्रिक्ट और खड़ूस और एंग्री हो सकता है, कभी नर्म और हेल्पफुल हो सकता है. स्टूडेंट्स भी कभी बहुत सिंसियर और स्टूडियस हो सकते हैं, कभी कभी वो नॉटी भी हो सकते हैं. ऐसे केस में वी नीड अ स्टूडेंट मेंटर और अ ट्यूटर जो कि इन दोनों के बीच में कभी कभार अगर कॉन्फ्लिक्ट हो सकता हो तो उसे मैनेज कर ले, और वही स्टूडेंट मेंटर है हमारा ये zener diode. This zener diode is here. This zener diode is employed here to ensure that all the minor fluctuations and variations can be handled easily. Now this student mentor also has some specifications. For example, इसकी कुछ minimum qualification है that at least a graduate can be a mentor or a tutor. जैसे कि इस zener diode के लिए भी फॉर एग्जाम्पल हो सकता है एनालॉजी इतनी एक्यूरेट ना हो, बट दिस zener diode also needs some IZ minimum to start conducting. एंड सिमिलरली कुछ मैक्सिमम स्पेसिफिकेशंस भी हैं, जैसे स्टूडेंट मेंटर सिर्फ इतने ही आवर्स तक काम करेगा, सिर्फ 6 आवर्स तक काम कर सकता है, उसके बाद उसके लिए वर्क लोड बढ़ाया ना जाए. ऐसे ही ये जो zener diode है, इट कैन अलाउ ओनली दिस IZ मैक्सिमम और दिस PZ मैक्सिमम. इसके बाद अगर इसे लोड दे दिया गया वो काम नहीं कर पाएगा, मेंटर बेहोश हो जाएगा. तो ऐसी सिचुएशन ना आ जाए एंड स्टूडेंट मेंटर छोड़ के भाग ना जाए, बेहोश ना हो जाए, वी नीड अ डिवाइस और वी नीड समबडी हु कैन लुक आफ्टर दिस zener diode. एंड हियर कम्स दिस करंट लिमिटिंग resistor. This resistor is present here to ensure that the incoming current does not exceed its value, and that is why this limiter resistor is employed here. So this is a voltage regulator circuit. Now let's have a look at this circuit. We have a power supply which is Vi, which may vary. We have a current limiter resistor which has some voltage drop across it. This is Vs, and some current flows through it, which is indicated as Is. We have a zener diode which allows the current to flow in this reverse direction. The current is indicated as Iz, and the breakdown voltage value is Vz. The maximum allowed power dissipation is PZM. We have a load resistor which has some voltage drop across it, VL, and the current flows through it, IL. So keeping all these terminologies in mind, as long as the incoming voltage is less than the breakdown value, it behaves like an open circuit. And how can we calculate whether the diode is on or off? Let's calculate the value across this point. This is the parallel connection, so this V will be equal to the voltage drop across the load resistor VL. Now if we want to calculate the voltage drop across this load resistor VL, the value of VL, we have a special formula which is called potential divider method. We have two resistors here, they are connected in series. We have this RS and RL, they are connected in series, and the voltage VI is being divided into two parts, VS and VL. So potential divider method allows us to calculate the voltage drop across any of these resistors. Right now we are interested in RL, so we'll calculate VL using this formula. The main supply voltage VI into RL, the resistor in which we are interested, upon the total amount of resistors RS plus RL. Using this formula, we can calculate the value of voltage drop across the load resistor specifically. Once we calculate this value VL, this point Vi is parallel to VL, so V will be equal to VL. We can calculate the amount of voltage drop here. If this voltage V is less than the breakdown voltage Vz, then the zener diode is turned off and it ideally behaves like an open circuit. The zener diode is not in this scenario right now. ऐसा अज्यूम कर लें कि इस टाइम प्रिंसिपल भी बहुत हैप्पी है और स्टूडेंट्स भी बहुत सिंसियर हैं, वो दोनों आपस में बैठ के पढ़ाई कर रहे हैं. वी डू नॉट नीड एनी ट्यूटर राइट नाउ. ये वो सिनेरियो है जब zener diode ऑफ है. And using this formula we can calculate the value of VL. जब हम वो calculate कर सकते हैं तो हम IL भी calculate कर सकते हैं. IL will be equal to VL upon RL. This is the current flowing in this resistor, and we can calculate the current flowing in the limiter resistor as well. IS is equal to VI, जो यहाँ पे voltage drop है इसकी supply, और VL इसको माइनस करके एक सिंपल फॉर्मूला है, वी कैन कैलकुलेट द वैल्यू ऑफ IS. नाउ डायोड इज ऑफ, देन वी इमेजिन दैट वोल्टेज या लोड कुछ वैरी कर रहा है. फॉर एग्जांपल सप्लाई वोल्टेज VI अब इंक्रीज होता जा रहा है. जैसे वो इंक्रीज होगा एंड द मोमेंट द VI रीचेस टू अ वैल्यू के ये जो पॉइंट V था इसकी वैल्यू अब VZ से कम ज्यादा हो गई है, VZ से ज्यादा हो गई है. नाउ द डायोड स्टार्ट्स कंडक्टिंग एंड बिहेव्स लाइक a battery. The breakdown is triggered. It behaves like a constant voltage source. Now this has become a battery. The zener diode works like a battery. It is allowing the excess of current to flow across it. जो ज्यादा करंट है वो इसके अक्रॉस फ्लो कर रहा है, एंड इट इज प्रोवाइडिंग अ कांस्टेंट वोल्टेज टू दिस लोड. दिस लोड is constantly receiving a VZ value across it. It's not connected to this VI directly, it's connected to this VZ now. Thank you for watching the video. Click on like, share it, and subscribe to the channel. Keep learning with Let's Learn Electronics. In case any of my viewers need some help in their assignments or writing tasks, please connect with us on Let's 0learn0electronics@gmail.com. Stay connected and wait for the next video.